Okay, so hopefully you've taken your chapter 3 and 4 test and you did well on that. You're on the home stretch. We're on the last 2 chapters for the semester. So this is starting chapter 5. We're going to learn how to add and subtract polynomials. But first, a joke. Did you hear about the mathematician who's afraid of negative numbers? He'll stop at nothing to avoid them. Think number line there. Ha ha. Okay, so when we're talking about polynomials, remember that those are it's a term or a sum of terms that contain both constants and variables. So just for reference here, monomials have just one term. So that would be something like, just a 3x squared, something like that. A binomial is going to have 2 terms in it. So if we said something like 2x squared minus 5. A trinomial has 3 terms in it, so that could be something like 4x squared minus 3x plus 2. So you see we have 3 terms there. So each one of these is considered a term. So there's a term, there's a term, there's a term. And that's what we're talking about. So anything after a trinomial, after 3 terms, is just referred to, its numbers. So there's 4-term polynomial, 5-term polynomial, or whatever. They don't really have specific names after that other than just their number. So the standard form of a polynomial is always written in the order of descending powers. If you noticed, in this example here, I did put the x squared first, and then the x, and then the plain constant. So if you have something like this, notice how they're in descending powers order. So powers means the exponent. So we're at 4, then 3, then this one has an exponent of 1, and then this one doesn't have any at all, so we would say it's an exponent of like 0. But they're in descending power of your exponents is standard form to be able to write those. And when we talk about polynomials, we also talk about the degree of a polynomial, and the degree refers to the highest degree of any term that's in that polynomial. So like in this case, the highest one is a 4 because of this 4 as my exponent right there. So we would say that this is a 4-degree polynomial. And then we would also say this is a 4-term polynomial just because it's got 1 term, 2 terms, 3 terms, 4 terms. And so if you had something like x cubed minus 5, that would be a 2-term polynomial, but it would have a degree of 3 because of the exponent 3 there. So hopefully that explains some of the vocabulary that we would be using in this section. And so what we're going to do here is start adding polynomials. And remember that we can only add those like terms, and like terms mean that they have the same variable, so it's either x or y or whatever, and it's taken to the exact same power. So we can only add x cubes with other x cubes. We can only add x's with other x's. And remember, we don't change those exponents when we are adding and subtracting. We only change those exponents when we start multiplying and dividing. So let's just look at this one here. We have, we're going to add negative 11x cubed plus 7x squared minus 11x minus 5. And then we're going to add the polynomial 16x cubed minus 3x squared plus 3x minus 15. So all we're going to do, since we're just adding here, we're just going to see what all of our like terms are. So I have some x cubes here, and I have some x cubes here. So I have negative 11 there, and I have 16 over here. So how many does that make? Well, that gives us 5 x cubes. Now the next term that we're going to look at would be our x squareds. And sometimes people will, like when you're adding these together, you might come up with some kind of code so that you can sort of see that, make sure that you've gotten everything. So you can draw a straight line, you can draw a squiggly line, you can draw circles around them or mark through them as you add them together or whatever. But notice we have a positive 7x squared over here and a negative 3x squared on this other polynomial. We're going to add those together, so that's positive 7 minus 3, so that gives us 4x squareds. So then the next term that we're going to add together, because we're going in those descending power orders, is going to be this negative 11x and the 3x over here on that side. So 11 minus 3 is 8, or negative 11 plus 3 is negative 8x. You notice we're only adding and subtracting those numbers. We are never changing that variable. And last, then, we have this negative 5 and a negative 15. We're adding those together, so that makes negative 20. And that is your final answer, because we've joined all of our like terms together, and that's as far as we can go. We can't join any other terms. All right, so you might want to try this one on your own and see how you do. This isn't that bad. So first off, let's look and see how many, what are our like terms. Well, we've got some x squareds. So we have 11 on this side. We have 12 over here. Add that together, we get 38 x squareds. All right, so let's just go down in descending order. We have 7x here. We have 10x over on that side. So that makes 17 x's. Then we're going to have our negative 4 and a negative 20. So negative 24. There's your final answer. All right, so adding them together is pretty easy. Just, the most common mistake is to think that you're adding those exponents also. And remember, when you're adding terms, you're just adding how many of those like terms do we have. Okay, so now let's go into subtraction, because there's a little extra when we have to subtract two polynomials. And so here we have this one polynomial and this other one is being subtracted. So remember that anytime we have that negative sign or that minus sign that's in front of a set of parentheses, it's like we have that imaginary 1 there. So we have that like negative 1, and we've got to go change all the signs of all the terms that are inside that polynomial. So first off, we're just going to rewrite this with distributing that negative sign or that minus sign throughout that polynomial. Then that just has us adding together like terms after that. So if I take that minus sign and I distribute it to that 2x squared, that gives me a negative 2x squared. If I distribute it to that 4x, it gives me a positive 4x, and then a positive 6 at the end. So remember that you've got to go change the signs in that second polynomial and then add like terms together. All right, so now let's go look and see, what do we have for like terms? We have a 9x squared and a negative 2x squared. So 9 minus 2, that gives us 7x squareds. So now how many x's do we have? We have positive 7x and a positive 4x. That gives us 11 x's. Then we're going to look at our constants, our negative 2, and we have a positive 6, so that gives us 4. And so that's your final answer. That's as far as we can go. All right, so sometimes it's not going to be written like that. It might say subtract, like in this case, 3x cubed minus 8x squared minus 5x plus 6 from 10x cubed minus 5x squared plus 7x minus 2. So when it says we're subtracting this polynomial from this polynomial, this is really the one that's being subtracted here, this 3x cubed minus 8x squared minus 5x plus 6, because it's being subtracted, so it's got to have it's the one that's got the minus sign in front of it. So if we were to set this up, we would say this is our original one. So 10x cubed minus 5x squared plus 7x minus 2. Okay, this is the one that's being subtracted, so we're going to have to go change all these signs. Now this one I'm going to line up vertically for you instead of lining it up horizontally where all your terms are just listed in a row. Sometimes as these things get longer, it's easier to just go ahead and line up any like terms that you have. So I'm going to distribute the subtraction part to all these as we line these up, and then we'll just add together our like terms. So this is going to be a negative 3x cubed once this is distributed. That would be a positive 8x squared. That would be a positive 5x, and then a negative 6. So just remember, anytime we're subtracting, we have to change those signs in that polynomial that's being subtracted and then add together our like terms. All right, so how many x cubes do we have? So we've got 10x cubes plus negative 3x cubes, so that gives us 7. We have negative 5x squared plus a positive 8x squared, so that gives us 3x squared. Then 7x plus the 5x is 12x's, and a negative 2 plus a negative 6 makes negative 8. And there's your final answer. Okay, so you see how you can do them horizontally, you can do them vertically. Either way, we can try it both ways if you want to. So we've got 8y cubed minus 10y squared minus 14y minus 2. And I'm going to go ahead and distribute the minus sign because I'm subtracting the entire polynomial, so I have to distribute that sign, change all those signs inside that polynomial. All right, so now let's find our like terms. 8x cubed and a negative 5x cubed, or y cubed, sorry, that's 3y cubes. We have negative 10y squared, and we don't have any others, so we're just going to put negative 10y squared. So then we have negative 14y and positive 3y. That leaves us with negative 11y. And then we have a negative 2 and a negative 6, so that makes negative 8. Final answer. So notice, even though we didn't have a term to join with this y squared here, he still had to get listed because he is part of our equation. So, and that is it for addition and subtraction of polynomials. Hopefully you won't have too much trouble with that. Just remember to distribute that minus sign on that polynomial that's being subtracted.